Hello everyone, in this video I'm going to solve some examples about linear equations, and let's see, uh, in in this first page here, I'm going to check whether these are separable or linear. At this point I think you have seen the two different types, so we want to identify whether it's separable and use the method for that, or linear and use the method for that, or if they're not to use and figure out what else we can use. So that's the goal. So let's do a quick review on this first one. So separable means I have the derivative equal to some function times another function. This, let's say, it needs to be dependent only on x, and this needs to be dependent only on t. If I can achieve that, then it is separable. So now let's look at the function that's given. It looks like we can do that with the x there being in the exponent and here being this factor. So no. Okay. Now let's do linear. Linear, it has a kind of, just like you're used to in linear algebra. You have this first derivative times some a1 of x, right? Not a1 of y, plus some same thing times y, not y squared or y cubed, equal to b of x. So these are connected to the independent variable, and we have dy there. So here, the dy is the dx, and the dx is the dt in this example. So let's write it here. Then the others will answer. So dx over dt minus 4x. Just if we want to do a comparison, here is the dx. Here is dx. Okay. What else? Now I have dt here. This, I don't have anything here, which is good. But here I also have t, which is small. And here I have 7 to ex, which is, no, I need to be there. So you can see what's going on. All right, so if I have the independent variable to be t, then this should be a function of t, right? And that makes it not linear. All right. So now let's ask the questions. What do you think about the next one? I kind of try to use the same idea. Separable doesn't look like it, but let's check whether it's linear. Linear, let's look at it. So you have 5et over dy over dt plus y dash log of t equal to t. All right, so I'll do the same thing. Here is dy, all right, I have y here, which is expected, it's okay. But now let's check the others. Here is dt. This function is dependent on t, which is good, and this one dependent on t, which is good, and this is dependent on t, which is good. So linear. All right, let's do this one as well. The x is there. Ah, x is here. So this should be dependent on t. This is t, t. So this de dependent on x, not t. So not linear. And of course, separable, you can check it's not. So let's just say that you can check separable, which doesn't look to be. All right, the last one here, it probably would look like, is it separable? No, because dr over dt, let's do it. So when you do this, and you bring in this here, that doesn't give you p times g, right? So no, but linear, say, there is dr right, so, okay, for linear, it's easy maybe to confuse this one. So what I will do, I will write it in this form. That's linear. Okay, so dr by d theta, because this is may look to be a problem myself, but if I put it here and I put the other there, now let's use the colors. dr r, that's okay, expected, just like ui and y is expected. All right, so I have function of x dx, function of x, function of x. So function of theta, d theta. So yeah, it's medium. Okay, so as you see mostly in softwares, that is a ignore lost solutions, if any. And we'll get to those examples. And for now, let's try to solve. And of course, at this stage, you've seen, let's say, separable one linear, and you want to see what type of equation you have, and you solve. In this section, it is about linear. So if I try to write this as dy over dt, I'm not going to be able to separate the t and y by factor or something. So let's just see if this is linear and we'll solve it. So dy over dt, when you take dy to the right side, you're going to have this left side, then you divide by dt, and you're going to have this left here, right? So this is where you see it's not separable, but it is linear. Why it is linear? Because I'll take it to that shape that I put here in here. This one minus y equal 5t plus 1. All right, so if we use again the colors dy, we expect y there. But now for the others, dt, that looks good. So the method says once you have this, you need to calculate the integrating factor using this formula. I'll remove this because it's either x or t, right? So let's just put p. And here, since dt is the independent variable, so it's going to be to dt. Right, so whichever independent you have. So p is, of course, what's in here, which is 1 negative 1 dt equal to, this is just going to be negative t, right? Then you're going to multiply this equation that is in standard form. This is in standard form, but let's multiply the equation that came up with this integrating factor, because when you multiply, it gives you that product rule that I explained in the previous video. So if you didn't see that, you want to see that, you see how this step gonna go to the next one and gonna get something. Yeah, so here we have a product rule. So function times a derivative plus a derivative times a function. So this is going to be this. Yeah, once we do this mu correctly, this is just goes that way automatically. The p times the y. And of course, integrate next. So this derivative here is moved. Of course, think about if you differentiate this, you will get that. All right, integrate. Then you get the left side out. And I'm going to separate. So yeah, so this is one integral and this is another integral. Also, if you wonder what's going on, you want to carry, so it's good as you follow the video to also write and say, okay, what happens here? So that's kind of what happens. So we're going to integrate the kind of these terms here because we have addition, and here they are, and you put, of course, the constant. All right, so what happens here? This we can do directly, and this is done. So this we need to check. And since we have t times e to negative t, that means integration by parts. Integration by parts. Right. So let's say u is a t, which means du is dt. Then dv is e to negative t dt, which makes v to be negative e to negative t dt. So if you differentiate this, right, you're going to get this. Okay, so that's what is next. We're going to do that. It's, excuse me, it's uv, u times v minus the integral of v du, which is dt. All right. Of course, we've done this now a few times. So this is the formula for the integration by parts. Okay, so this is now just this integral here. Let's call it I. Let's just now we're working on. Okay. So now let's put this into the main solution. And let's not forget the 5. Maybe let's highlight. So let's not forget the 5 times the answer, which will be integrated. And of course, we will have a constant from it, and we have a constant. So we're going to put one constant at the end. You can call them C1, C2 and stuff, but it's one constant towards the end. All right, so negative 5 times t times this exponential function minus, we integrate this one, it looks like it's that because when you integrate, when you differentiate this, you get a negative, which we have, then times the 5. Now I'm going to move to this, which is this one, then the constant. Anything to simplify? Yeah, this one. Negative 5t to e minus 6 times this exponential function plus c. All right, so what's next? Is to divide by mu. Right? That's divide by yes, which gives you y equal all this stuff. Simplify, simplify. And this we can leave it here, or it comes here and becomes positive. Okay. So y, the general solution is negative 5t minus 6 plus c. Yes. You know, we can do whichever. This, what is this? Okay. Okay, so in this example, to solve this equation, and put in here the colors to show you it's linear, and don't get caught up in y has to be a function of x. You know, these are just variables. You can switch it to whatever you want, and at the end replace, just like we do with the use substitution. Then say this variable I called it this, and this variable I called it this, and when you get your solution, you put it back. It doesn't matter. What matters here is x is dependent and y, right? So the solution is to be written this way. Okay. So let's divide by y so we can get the integrating factor. Okay. So it is u is e to integral of this thing and dy, which means e to 6 natural log of y, which means e natural log of y to the 6, which means y to the 6th. So mu is y to the 6th. Now multiply, we're going to multiply the equation by that, and multiply by this one. So y to the 6th times by y plus 6 over y times y to the 6 times x equal y to the 7 times y to the 6. As I mentioned, and if you saw the previous video, this will only give you mu times that dependent variable using the product rule. And this, not yet, I keep going to it quickly. Then integrate, now y to the 6 times x equal 4y plus c this is a power function. Then reduce. Now divide by y to the 6th, and we'll get y14 divide by y to the 6th. We subtract 14, 8 from 14, and then we get this. Okay, so by now you've seen different types. The straightforward ones, we're not dealing yet with some other issues, and I will do these types. Maybe the next one I will do is the one where you have to deal with the absolute value, and we'll see how we deal with that, and we'll keep in mind, the other ideas in other types of problems. But I think for this video, I'm going to stop here and do another one with the examples that involve having the absolute value and see how to deal with that. Okay. Thank you.